Hi everyone. For this problem, we will be starting to use the famous formula PV equals mRT. This formula comes in everywhere, and I think there will be lots of exercises so that we can get familiar with it. So let's get into it. P is for the pressure of a gas, V is its volume, and T is its temperature. Now the small n here is for the number of particles in the gas expressed as moles. But we don't actually need this n for this exercise, so it will be a good example of an exercise where we don't need to use the whole equation and only part of it. Alright, so what is the problem? We have 3.5 meters cube of a gas. So let's draw a cube and imagine that there is gas in it. 3.5 meters cube of it. And it is placed at standard temperature and pressure, STP. This means the pressure is 1 atm and the temperature is 273 Kelvin. Now, we place this volume of gas under a pressure of 3.2 atm. So something changes. And now our cube will be different. The pressure is now 3.2 atm, which is higher pressure. And when we do that, we observe that the temperature of the gas rises up to 38 degrees Celsius. 38 degrees Celsius in Kelvin is 311. So one thing will become very important when we use the ideal gas law, this one, is that temperature is always Kelvin. Always Kelvin in this equation. And the thing we want to know is the volume in the final setting here. I will write it VF for volume final. Alright, so we have pressure, we have temperature. We want to know volume. Looks like this equation is going to become handy, but we don't have the number of molecules of gas. So we can't just use this equation directly. We will have to use a trick. And this trick is that this equation holds true before and after. So before, we can write pressure initial, volume initial, and I could keep writing it, but before we do that, let's just divide each side by temperature. So that here, just trying to erase. Alright. Here, the temperature disappears on this side. This eraser is not awesome. Anyway, we've basically moved the temperature on this side of the equation to this side of the equation. So now I will write this down. PV divided by T is equal to NR. Now that also holds true of this. In the final conditions, NR is also equal to PV over T. And now you can understand why we're not going to need to know the number of particles, because we will use this side of the equation and make it equal to this side of the equation. Excellent. Now in this equation, we want to know what Vf is, and we know the value of all the other variables. So we can simply rewrite this as Vf equals, I'm really writing it down explicitly for you guys, like that, and then Tf goes up, Pf goes down, and now let's plug in the numbers. We have 1 atm for initial pressure, we have 3.5 meters for the initial volume, and we have 273 Kelvin, that for the initial temperature. And then the final temperature, we have 311 Kelvin, and we have 3.2 atm. Right, and when you calculate for all those numbers, you get a final volume of 1.25 meters cubed. And that matches the answer in the solution book.